So for the first problem here, we are adding. Remember, when we add or subtract, we need the same name. So for fractions, that means common denominator. So for 4 and 6, that's going to be a common denominator of 12. So 1/4 will become 3/12. 5/6 will become 10/12. Now when we add 3/12 plus 10/12 is 13/12, which is bigger than 1, so we have to break that into a mixed number. So 12 goes into 13 once with 1/12 left over. So 1/12 carry the 1. 1 plus 3 is 4, plus another 4 is 8. So we get 8 and 1/12. Number 2, subtraction. We also need a common denominator. For 6 and 8, what is our common denominator going to be?
24.
24. Very good. So 6 times 4 makes 24. So 1 times 4 is 4. 8 times 3 makes 24. So 7 times 3 is 21. Now we go to subtract here. We see 4 24ths minus 21 24ths can't be done. So we need to borrow. We borrow from the 8. That becomes a 7. What do we do to the 4 here?
And 7.
Careful.
Wait. No. That'd be it.
Yeah, what we borrowed was one whole object. That denominator tells us that whole object was 24 pieces. So we have to add 24 of those 24ths to the 4, giving us 28 24ths. So whatever the denominator is what we have to add to our numerator when we borrow. Now we can subtract 28 minus 21 is 7 24ths. And 7 minus 5 is 2. So 2 and 7 24ths. Number 3, when we multiply or divide, we do not need the same name. So that means we do not need a common denominator. It does, however, remember we looked at that process of multiplying mixed numbers is kind of difficult, so we're going to turn these into improper fractions. Come on now. 4 1/3, what does that become as an improper fraction?
4 1/3. 13 over 3.
13 over 3, good. 2 3/5, what does that become?
13 over 5.
13 over 5, good. Now we multiply. 13 times 13 is 169. 3 times 5 is 15. And now probably the toughest part is breaking this back into a mixed number. So we're going to divide 15 into the 169. Well, 15 goes into 16 once. We subtract, there's 1 left over. We bring down 9. 15 goes into 19 once. We subtract, there's 4 left over. That's 11 with 4 pieces left over. So 4/15 left over. Number 4, for division, since we're going to turn it into multiplying by the reciprocal, it makes sense that we start out the same as we did with multiplication. We're going to make them improper fractions. So 5 1/3 is going to become what?
16.
16/3, good. And 2 2/5 will become
12 over 5.
12 over 5, good. Now we have to change this into multiplying by the reciprocal. Remember, the first fraction is not affected. The division operates on the number that comes after it. So it becomes times 5 over 12. Now we can cross cancel. This is multiplication, and like any other multiplication, we can cross cancel. 16 and 12 both divide by
4.
4. Good. 16 divided by 4 is 4. 12 divided by 4 is 3. So 4 times 5 is 20. 3 times 3 is 9. 20 divided by 9, well, 9 goes into 20 twice with 2 left over. 2 and 2 ninths is what we get there. Any questions? Okay, so an example of a problem with fractions that I wanted to make sure I go over here. A nut is advanced 12 turns on a 1/4 inch 24 NF bolt. How far does the nut advance? So to understand this problem, the first thing we have to understand is, what does all this mean? 1/4 inch 24 NF. Well, first of all, the 1/4 inch is the diameter of the bolt, means nothing to this problem. The 24 NF, NF stands for National Fine. It's for threading on bolts and screws. 24 means it is 24 threads per inch. In other words, 24 threads equals 1 inch of bolt. 12 turns means every 1 turn means it advances 1 thread. So 12 turns means it has advanced 12 threads. So how far has this nut advanced? It has advanced 12 threads or 12 turns out of 24 that makes a whole inch. We can reduce that fraction. Both 12 and 24 can be divided by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. That bolt has gone 1/2 of an inch. By taking the number of turns of the nut, I should say that nut has gone 1/2 of an inch. By taking the number of turns of the nut over the number of turns it takes to get a whole inch, we can get a fraction of an inch that nut has moved up that bolt, has advanced on the bolt. That question is kind of important because there is a quiz. Quiz 3 is out there that is due by noon tomorrow, so September 16th. And there's quiz 4 that's also out there. That is not due until Thursday. That's going to be on the material we discussed today. So make sure you do quiz 3 first. That is on fractions. And there may or may not be a question very similar to the one we just went over here on quiz 3. So today's topic, we're going to talk about decimals. And the key to understanding decimals is back to that same simple concept we talked about for whole numbers. That comes back to place value. So if we look at our place value, starting at our decimal and working our way backwards, this is the ones place, the tens, the hundreds, 1,000s, 10,000s, 100,000s, and it continues on up. But I wanted to label them with numbers like this so you could see the pattern here. Boy, that's crooked. Anytime I move one place value to the right, the value of that place is divided by 10. 10,000 divided by 10 is 1,000. 1,000 divided by 10 is 100. 100 divided by 10 is 10. And if we keep going, of course, 10 divided by 10 is 1. That pattern continues on the other side of the decimal point as well. 1 divided by 10, of course, is 1/10. 1/10 divided by 10 is 1/100th. 100th divided by 10 is 1,000th. 1,000th divided by 10 is a 10,000. 10,000th divided by 10 is a 100,000. And that pattern continues. Well, you might be looking at these place values here and thinking, those look suspiciously like fractions. Well, that's all that decimals really are. In fact, many textbooks refer to them as decimal fractions. They are nothing more than fractions that have very specific denominators. In our number system, those are denominators with that are powers of 10, 10, 100, and so on. So if I have a decimal, 0.48, that's really just a shortcut way, abbreviated way of writing the fraction 48 hundredths. We take the number that's after the decimal point, that was the 48, and the denominator is the place value of that last digit. The 8 is in the hundredths place, so that's why it's hundredths. And it's really just that simple to turn a decimal into a fraction. 0.48 becomes 48 hundredths. Now, in most cases, we would want that fraction reduced. What do both 48 and 100 divide by? They're both even, so they can be divided by 2, but they can both be divided by 4. 48 divided by 4 is 12. 25 divided by 4, or 100 divided by 4 is 25. So 12 25ths is as far as we can reduce that. What if I had 3.0625? Well, the part in front of the decimal point doesn't affect the fraction at all. Just like we have mixed numbers and fractions, where we have a whole number in the fractional portion, we have mixed numbers in decimals. That 3 is a whole number. Now the 0.0625, well, again, we have the 625, and we put it over the place value of that last digit, 10,000. Now, typically, we won't have the place values written out like this, but we can count tenths, hundredths, thousandths, 10,000ths. A little shortcut to double check yourself. I'm not a huge fan of shortcuts, but this is a handy one. You count 1, 2, 3, 4 decimal places. 1, 2, 3, 4 zeros in my denominator. Now I have to reduce this fraction. Both 625 and 10,000 can be divided by 25. 625 divided by 25 is 125. 10,000 divided by 25 is 400. Sorry, 625 divided by 25, yeah, is just 25, not 125. Now those can both still be divided by 5. Actually, they can still be divided by 25. 25 divided by 25 is 1. 400 divided by 25 is 16. Can't remember, or forget to remember our whole number here, the 3. So that's 3 and 1/16. 3.0625 is 3 and 1/16. Well, let's look at our operations with our decimals. Remember when we add or subtract. One is we must have the same name. Well, we mentioned this a couple weeks ago for decimals. That means line up the decimal points. Making sure that we have the place values lined up, so we're combining digits with the same place values. Of course, we're going to combine counts. We always combine counts. And then we're going to keep the same name. For decimals, keeping the same name means dropping the decimal point down. Straight down. So when we add or subtract, whenever we cross the decimal point, we have to make sure we do something with it. So if we look at some examples here, 25.38 plus 7.952. So we write this out, write our first number out. I typically then put the decimal point in for the second number right away, so it's right below the first one, and fill in the number around it. So 7.952, and we're adding. So we'll go ahead and add. Now what I should do here before I add is fill in the zeros for those missing decimal places. So I put a 0 in there. Now I can add. 0 plus 2 is 2. 8 plus 5 is 13, so it's 3. Carry the 1. 1 and 3 is 4, plus 9 is 13. That's 3. Carry the 1. Notice the decimal point did not affect my carrying at all. I just totally ignored it, carried right past it. But now that I'm passing the decimal point, I do have to bring it straight down. 1 and 5 is 6, plus 7 is 13 again, so 3, carry the 1. And 1 and 2 is 3, so 33.332. So something like this, same way. 7.863, I put my decimal point in first. 0.45. Again, I should fill in that missing decimal place with a 0. And then we'll add. 3 plus 0 is 3. 6 plus 5 is 11, so 1, carry the 1. 1 and 8 is 9, plus 4 is 13. So 3, carry the 1. Before we do the next column, next place value, we drop our decimal point, and 1 and 7 is 8, 8.313. Subtraction works the same way. We might have 29.473 minus 6.94. So again, we set this up, write out our first number. And our second number, we put our decimal point in and we fill in around it. Just like with addition, we should fill in the missing decimal place, so we do. And we'll subtract. 3 minus 0 is 3. 7 minus 4 can't be done. We're going to borrow from the 4 to make it a 3. This is now a 17. Oops, 7 minus 4. That can be done. What am I thinking? Let me backpedal a little bit. 7 minus 4 is also 3. 4 minus 9 cannot be done. So we borrow from the 9. This is 8, and this is 14. Notice again, the decimal point did not affect my borrowing. 14 minus 9 is 5. Again, we bring the decimal point straight down. 8 minus 6 is 2, and then we have the 2. Now in this case, the missing decimal place was in the second number, the number being subtracted. It didn't affect us so much. But let's look at an example like this of 8 minus 2.3651. So we set this up. First of all, there's no decimal point written with the 8. Well, if there's no decimal point written, it's at the end of the number. If there's no places after it, we usually don't write it in. So that's 8. I'm going to put the decimal point after it so I can line up my next number. So the 2.3651, and we're subtracting. Now here, since it's the first number that is missing the decimal places, I have to fill them in with zeros or I can't do the calculation. Now I go to do 0 minus 1, can't be done, so I go to borrow, but there's nothing to borrow from here. So I have to keep going. I go all the way over to the 8 to find something to borrow from. That becomes a 7. Borrowing from the 8 makes this into a 10. Well, I need to get it all the way down here, so I have to keep borrowing. So I borrow from that 10 again. This is a 9, and this becomes a 10. Borrow from the 10 again. That's a 9. This is a 10. One more time. I borrow. That's a 9. This is a 10. A lot of you are probably taught a shortcut just to borrow, and it's 9, 9, 9, 10. Same difference, but you're really borrowing over and over again. So now we have 10 minus 1 is 9. 9 minus 5 is 4. 9 minus 6 is 3. And 9 minus 3 is 6. We hit our decimal point, so we bring it down. 7 minus 2 is 5. That's addition and subtraction. Now, I'm a realist. I realize you have the calculator. Decimals go in the calculator nice and easy. But like we mentioned before, do some estimation. Look at this and say, okay, that's 8. This is about 2. 8 minus 2 is 6. I'm expecting something around 6. Because on many calculators, when you push the decimal key, the decimal point doesn't show up on the screen until you press the next number. The decimal is the one key that is the most often missed on the calculator. So you could screw up and that decimal doesn't register. You can end up with some really weird answers if you're not keeping track of what your estimate should be. Well, when we multiply or divide, remember, we do not need the same name. We're going to combine counts. And then we're going to also combine names. So we've got to figure out how to combine the names, account for combining the names in our operations here. Well, if I have something like 2.56 times 0.735, I do not have to line up the decimal points. Now, I could have switched the order if I wanted to and put the 2.56 on bottom. It really doesn't matter. I'm going to have to multiply by 3 different digits anyway. Now, I'm going to totally ignore the decimal points here until the very end. Just like with whole numbers, I'm going to start with the last digit of the bottom number, and I'm going to multiply through the top number. 5 times 6 is 30, so that's 0, carry the 3. 5 times 5 is 25, plus 3 is 28, so 8, carry the 2. 5 times 2 is 10, plus 2 is 12, so that's 2, carry the 1. There's no place to carry it, so we just move it over. Now we're done with the 5, we're going to move over to the next digit, to the 3. We've been taught that when we do that, we have to add a 0 down here. I also put a line up here just so I know those are old carries. Anything below the line is an old carry. Now I have 3 times 6 is 18, so that's 8, carry the 1. 3 times 5 is 15, plus the 1 is 16, so 6, carry the 1. 3 times 2 is 6, plus 1 is 7. I'm done with that one, so now I'm going to move over to the next digit, which is the 7. Now, technically what we were told was not that we just have to add a 0, but we actually have to add a 0 or move over a spot for every digit to the right of the one we're working with. There are 2 digits to the right of the 7, so we have to put in 2 zeros down here. So now we have, and I put a line up here so we know those are old carries. 7 times 6 is 42, so 2, carry the 4. 7 times 5 is 35, plus 4 is 39. So 9, carry the 3. 7 times 2 is 14, plus 3 is 17. So 7, there's no place to carry the 1, so we just move it over. We'll now add these digits here. We've got 0. 8 is 16, so 6 carry the 1. 1 and 2 is 3, plus 6 is 9, plus 2 is 11, so 1 carry the 1. 1 and 1 is 2, plus 7 is 9, plus 9 is 18, so 8 carry the 1. 1 and 7 is 8, and then we have the 1. To place our decimal point, need to get rid of all this here a little bit so I can see better. We count the number of decimal places in our problem. We have 1, 2, 3, 4, 5 total decimal places in the problem. So I start at the end of my answer and I count 1, 2, 3, 4, 5 decimal places in my answer. Notice I still counted the 0. Even though it's a 0, it has to count. It is a decimal place. So I get 1.8816. The reason I chose this example is because that last digit is a 0. It's really tempting to just drop it off there. We cannot drop it off until we have located our decimal point. Of course, when we look at this, we think of this as being about 2 or 3, and this is about 1. 3 times 1, we're expecting an answer around 3. 1.8 is not close, but it's in the ballpark. 18.816 would not make sense, and 0.18816 would not make sense. So that's the only place it really makes sense to put our decimal in that answer. Well, let's look at division. Dividing by decimals. Let's do 47.32 divided by 3.2. Now, we looked at that process back on the second day where we used the place values and we multiplied out over here and subtracted and whatever. We could actually use that same process here. And we wouldn't have to worry about the decimal points at all. The decimal points would work themselves out. But since most of us are not familiar with that process, I'm not going to show you that. I'll go over this the same way as what we would normally do our calculation. What we do is, rather than dividing by a decimal, I move the decimal point over. I moved it over one place value here, though, so to balance it out, I have to move it over one place value there. So this becomes 473.2 divided by 32. The question is, why is that allowed? Well, we mentioned that division and fractions are kind of interchangeable. So we can think of this as 47.32 over 3.2. And if I want to get rid of the decimal point here in that denominator, I can multiply by 10. 3.2 times 10 is 32. Well, I multiply the denominator by 10, I have to multiply the numerator by 10. 47.32 times 10 is 473.2. Notice, so really, all I'm doing is using that fraction form of division to multiply both the numerator and denominator by the same thing in order to move that decimal point over. Now let's say I tell you that I want this calculated to the nearest thousandth. Well, let's take a look at how this gets done. So I'm going to start out, 32 does not go into 4, so I'll leave it blank above the 4. 32 does go into 47, only goes once. I put a 1 above the 7. 1 times 32 is 32, and we subtract. 5 and 1. We'll bring down the next digit. Bring down the 3. 32 goes into 153. That looks like 4 times. 4 times 32 is 128. So we subtract. We'll have to borrow here. This will be a 4 and a 13. 13 minus 8 is 5. 4 minus 2 is 2, and the 1s are good. Before we bring down this next digit, before we bring down the 2, we're passing the decimal point. We have to move the decimal point up. Now we can bring down the 2. 32 into 252. Not quite going to go 8 times. It's going to be 7. So 7 times 2 is 14, so 4 carry the 1. 7 times 3 is 21, plus 1 is 22. We subtract there, we get a difference of 28. Now we might be looking at that thinking, well, we're done, we're out of decimal places. But as long as we are after the decimal point, I can add zeros on the end of the number. And it doesn't change anything. So I can add that 0 and bring it down. 32 goes into 280. Let's see, will it go 9 times? No, it won't. It's going to go 8 times. 8 times 2 is 16, so 6 carry the 1. 8 times 3 is 24, plus 1 is 25. We subtract there, there's 24 left over. Well, we're only to the hundredths digit, so let's add another 0. Bring it down. 32 goes into 240, I'd say 7 times. 7 times 32 is 224. Subtract there to get 16. Now we're at the thousandths digit. Does that mean we can stop? Well, no. When I say I want it to the nearest thousandth, what that is saying is round your answer to the nearest thousandth. In order to round to the nearest thousandths, I have to know what that next digit is, so I know whether this stays a 7 or if it has to round up to an 8. So we do have to go at least one more digit. So I add another 0 and bring it down. 32 into 160 actually goes exactly 5 times. So to the nearest thousandth, which is this digit, I look at that next one's a 5, tells me that rounds up to 14.788, the nearest thousandth. Any questions? Now we've looked at converting our decimals to fractions. Now that we know how to divide, we can go the other direction, fractions back into decimals. We all know that 3/4 is 0.75, but if we didn't know that, to calculate it, we take the numerator divided by the denominator. So 3 divided by 4. Well, 4 does not go into 3, and there's no more digits to go. So we add the decimal point, we bring it up, and remember, we can add zeros after the decimal point without affecting the value of the number. So now we've got 4 goes into 30 7 times. 7 times 4 is 28, so we subtract, we got 2. We can add another 0, bring it down. Well, 4 goes into 25 times, and that's it. There's nothing left over. So 0.75. So homework. We got page 63, 65, 1 through 73, the odds. And page 72 through 75, 1 through 67, the odds. And don't forget, quiz 3 out there that is due by tomorrow at noon. So I'll let you guys have our last 12 minutes here to get started on the homework if you like. Or if you have a computer, you can start on the quiz. Or if you want to clean up your spot and get going, I am okay with that as well.